Hi friends, in this video we will learn how to solve transportation problem. To start up with the introduction, it is a special kind of LPP, linear programming problem, in which goods are transported from a set of sources to a set of destinations, subject to the supply and demand of the sources and destinations respectively, such that the total cost of transportation is minimized. Means this is all about transporting goods from warehouse to a particular outlet. And in order to supply goods from warehouse to the outlets, we should see that there are sufficient amount of units present, sufficient amount of products present in the warehouse. For example, now if I have a warehouse where I'm selling cement bags to the cement outlets, in that case I should have sufficient number of cement bags in my warehouse so that I would be able to meet the supply demand from the outlets every day. Now that is the meaning that transported from a set of sources to a set of destinations subject to supply and demand. Subject to supply and demand means we should see that there is sufficient amount of products that I will have in my warehouse maintained in order to meet the supply demand, such that the total cost of transportation is minimized. Means, like for example, at a time if I get order from 3 outlets to deliver 50 bags of cements for each, then I should see that I will have about 150 bags present in my warehouse. 150 cement bags should be present in my warehouse in order to supply 50 cement bags each for 3 different outlets. So I'll just carry all the 150 cement bags in the same truck, and I'll see that I will reach all the 3 destinations, which will again help me to reduce the transportation cost. There are 2 types of problems in transportation. One is balanced transportation problem and the other one is unbalanced transportation problem. How do we check if the problem is balanced or unbalanced? We will check it in the later steps. These are the steps involved in solving transportation problem. Finding the initial basic feasible solution and finding the optimization. So now in this video I will only try to show you all the methods to achieve only initial basic feasible solution. This is the way how the transportation problem is represented. It is always represented in the form of a matrix, and all the values within the cells of the matrix are nothing but the transportation cost, and all the values that I have in the outer column are nothing but the supply. Values in the outer row are nothing but the demand, and these columns are nothing but the destinations, and all these rows are nothing but the sources. Now for source 1, if source 1 has to supply, or for example now these are the destinations. Now A is one outlet, B is second outlet, and 3 is the third outlet, and this one outlet will have contact with all 3 different types of warehouse. I can supply the products from 3 different warehouses to each destination. Each 3 shops are in contact with 3 different warehouses. Now if I have to transport a goods from warehouse P to shop 2, then the demand here is the shop would need 200 bags, but in this warehouse I have 200 cement bags. Similarly, if I have to check for a product, if I have to deliver a product from warehouse number 2 to shop number 1, then it again needs 200, and the warehouse 2 has got 300 bags. Similarly, if I have to transport a cement bag from warehouse number 3 to shop number 1, then again the demand here is same 200. The shop needs 200 bags only for a day, and the supply here in the third warehouse is 500. Similarly, this is a shop number 2. If shop number 2 has to buy a, or if it has to get the goods transported from warehouse number 1, then the demand is 400 and supply is 200. Mean in warehouse number 1 there are 200 cement bags available. In shop 2 I need only 400 cement bags for a day. If shop 2 has to buy, or if it has to get a good transported, cement bags transported from warehouse 2 to shop number 2, then the total available number of cement bags in warehouse 2 is 300, but the demand here is 400. Similarly, if I have to transport the cement bags from warehouse number 3 to shop number 2, then the demand is 400. Shop number 2 needs 400 cement bags, whereas there are 500 cement bags in warehouse 3. Same thing can also be applied for the third column. So this is the way how your transportation problem is represented. All these values which are there within the matrix cells are nothing but the transportation cost. These are nothing but the rows indicate the sources, the column indicate the destination, and whatever values we have in the outer column are nothing but the supply, and whatever values we have in the outer row are nothing but the demand. To solve these transportation problems, there are three different types of methods. One is northwest corner cell method, least cost cell method, and this method has got two more different names: Matrix-Minima method, lowest cost entry method. And the third method is Vogel's approximation method, which is in short called as VAM, or there is one more name, unit cost penalty method. They might twist the questions in the question paper for your exams. So be careful. Before you start solving the transportation problem using any of these three methods, please check what is the type of the method you have to apply. If in case they ask you to find out they ask you to solve the transportation problem using Matrix-Minima method, then it is nothing but least cost cell method. And if they ask you to find out the unit cost penalty for the given transportation problem, then it is nothing but Vogel's approximation method. Now this is the given transportation problem for which we will have to find out the initial basic feasible solution using northwest corner cell method. Before we apply the method for the given transportation problem, let us first check if the given transportation problem is a balanced transportation problem. We make use of a simple rule to find out if the given transportation problem is balanced or unbalanced. The sum of availability, which is nothing but the sum of supply, should be equals to the sum of the demand. Now the sum of availability is 130 plus 150 plus 170, which makes up to be 450, and then the required, which is nothing but the demand, sum of the demand is 90 plus 100 plus 140 plus 120 will again lead to 450. So with this we conclude that the given transportation problem is a balanced transportation problem. Hence we identified that the given transportation problem is a balanced transportation problem. Now we are eligible to apply the method northwest corner cell to the given transportation problem. Now for the first instance, for the whole given problem in its entirety, I have 4 columns and 3 rows in the given matrix. I'll have to make use of this whole matrix to identify the initial basic feasible solution. Since it is northwest corner cell method, we will first have to find out the northwest corner cell for this whole given matrix in its entirety. For the whole given matrix, now the northwest corner cell would be the firstmost cell, which is nothing but the cell that has got the value 10. The firstmost cell of the matrix is nothing but the northwest corner of the given matrix. Since this is the first cell that will be encountered for the first iteration, we will make use of the column number 1 to find out the first iteration. Now since this we have identified to be the northwest corner, we will have to work on this whole column. Now first check what is the demand for the cell that has got a value 10. For the cell that is considered as a northwest corner, find out what is the demand. The demand is 90. And what is the supply for this whole row? It is 130. It indicates that in the refinery I have about 130 130 liters of oil available, and I'm actually demanding, the customer is demanding for 90 liters of what? Oil. So successfully I can satisfy the 90 liters oil demand. So I'll just write the demand here. We always write the least value amongst the demand or the supply as a kind of allocation to the encountered cell. Now we have made 90 to be the allocation for this cell. Hence the demand for this whole column has been met. No other columns or no other customers would be able to cross the same path. Hence to avoid that confusion, we will try to strike out this whole column. Once the demand has been met, or once the supply has been finished out, or supply has got over, supply has turned out to 0, we will have to strike out that path, because that path cannot be used by any supplier or neither by any of the customers anymore. Hence, for this given problem, from the first iteration we strike out the first row and we see that the demand is satisfied. Since the demand is satisfied, let me make it to be 0. Now, after satisfying a demand of 90 out of 130, I am left out with 40 here. Now I have a new matrix where I have 3 columns and 3 rows. For this whole new given matrix, find out the northwest corner. The northwest corner for this new matrix will be the cell, the firstmost cell of this new matrix, which has got a value 12. The firstmost cell of this matrix will be the northwest corner cell. Now it indicates that we'll have to make use of this column. Find out what is the demand given for this cell. The demand is 100. And what's the availability? It is 40. As I have already told, we assign the leastest value amongst supply or the demand as a part of allocation for the encountered cell. Now we find 100, which is greater than 40. So we make use of 40 as an allocation. We see that out of the 40 available products, 100 products cannot be satisfied. Since I don't have any other way to jump to other rows or to the other suppliers directly, I have to go with the suppliers according to the chronological order. One by one I will have to go ahead with. I cannot try to jump with the next supplier. See, for example, now if I encounter this, I cannot make use of the next supplier which has got a demand, which has got an availability of 150. Although my demand is 100 and the supply is 40, I will see that I will satisfy this 40 available, whatever is available. I'll just try to satisfy that and I'll see that this whole warehouse is closed. Since the supply is meant to be 0, I will not be able to make use of this path for any other customers anymore. No other customer can visit this path anymore because this availability has turned out to be 0. Now, out of 100, we have only satisfied 40. So, we are still left out with 60 here. Now, after the second iteration, I have the first column and the first row striked out. After the second iteration, I have a new matrix formed with 3 columns and 2 rows. Now again find out the northwest corner cell for the given whole new matrix. For the given new matrix, the northwest corner cell would be the firstmost cell of this whole matrix, which is carrying a value 11. And the demand for this value 11 is 60, but the availability is 150. Since 60 is lesser and also the demand has been completely met, I will see that I will allocate 60 here for the cell, and let me turn out the demand to be 0. Let me set the demand to be 0. After satisfying 60 products out of 150, I am here left out with 90 products. Since the demand has been met for this whole customer, I will just try to strike out this path, because no more suppliers would make use of any of these customers crossing this path. We will not let any of the customers or the suppliers cross the path for which the supply or the respective demand has been turned out 0. Now, after the third iteration, I have column number 1, column number 2 and row number 1 being striked out. I am left out with a new square matrix, 2 by 2 matrix with 2 rows and 2 columns. Now for this new matrix, the northwest corner cell would be the cell, the firstmost cell that carries the value 9, and the demand for this is 140, but the availability for this is 90. As I already told, we cannot jump to the other supplier. Although the availability is less, we see that we first cross that path and then take the next path to the next supplier. That leads to the next supplier. Since the demand is 140 and the availability is 90, I'll see that I will satisfy the customer with all the available products, and I'll just turn out the supply to be 0. After satisfying only 90 out of 140, I am left out with 50. Since the supply has been turned out 0 here, I will just try to strike out this whole row to avoid confusions, and we don't want any other customers nor any other suppliers to cross any of these paths. After the fourth iteration, I I'm left out with a new matrix that consists of one row and two columns. After the fourth iteration, I have column number 1, column number 2, row number 1 and row number 2 striked out, and I'm only left out with this new matrix. And for the new given matrix, the northwest corner cell is the firstmost cell, the cell that carries the value 7, that has got a demand of 50 and a supply of 170. Since the demand is 50, I will just try to satisfy the demand of 50, and I'll turn out this demand to be 0. And after satisfying 50 products out of 170, I am left out with 120 as the supply. Since the demand has been met for this whole column, I'll try to strike out this whole column, because I don't want any more customers or any suppliers to make use of the same path anymore. After 5 iteration, now I am left out with only one cell here, the only cell in the whole given matrix, and that cell has got a demand of 120 and also a supply of 120. So if the problem leads to such a situation where after all the iteration at the end, when you're only left out with one cell and that has got only a supply which is equals to demand, this indicates that the given transportation problem is a balanced transportation problem, and we have appropriately applied the method in order to achieve the initial basic feasible solution. Since now we have encountered such a situation where after all the iteration, at the end of the problem, at the end of the problem, I am only left out with one cell which has got a demand of 120, which is equals to the supply of 120. Hence, I will satisfy the demand and supply subsequently, and I'll turn out the demand also to be 0, and also the supply will be turned out 0. This is how we apply northwest corner cell for the given transportation problem, where we try to satisfy all the demands for each of the consumers with respect to suppliers, and at the end of the problem we see that all the demands and the supplies has to be set to 0. After this, the last step is to identify the total transportation cost. To find the total transportation cost, I make use of all the allocated cells. I multiply the values within the cell along with its allocated value and sum up with all the other values in all the allocated cells. Let us try to understand how do we do it. It is 10 multiplied by 90 plus 12 multiplied by 40 plus 11 multiplied by 60 plus 9 multiplied by 90 plus 7 multiplied by 50 and plus 8 multiplied by 120, which gives a total sum of 4160. Now this is how we apply northwest corner cell method for a given transportation problem. Now let us try to apply least cost cell method for the same transportation problem. As usually, before we start applying the least cost cell method for the transportation problem to find out the initial basic feasible solution, let us first check if the given transportation problem is the balanced transportation problem. To check the balanceability of the problem, just try to sum out the availability and required. The sum of required and the sum of availability should always be the same. If the sum of required is equal to sum of availability, then your given transportation problem is a balanced transportation problem. Since we have already solved this problem for northwest corner cell method, we already know that the given transportation problem is a balanced transportation problem. But then still, before we start solving least cost cell method for the same problem, let us first check if the given problem is balanced. The sum of availability 130 plus 150 plus 170 will give me 450. Similarly, the sum of the required, that is 90 plus 100 plus 140 plus 120, will also give me a sum of 450. So let me write 450 here. Now, let us start applying the problem, since we have come up to an opinion that the given transportation problem is a balanced transportation problem. With the sum of availability equals to sum of requirement, we conclude that the given transportation problem is a balanced transportation problem. Let us start applying least cost cell method. As the name itself indicates it is a least cost cell method. It is self-explanatory. You have to first find out for the leastest value in the whole given matrix. Now try to find out what is the least value in the whole given matrix. For this given matrix, 7 is the least value. So that is the cell that will be encountered in the first iteration. Since 7 is the least value in the whole given matrix, that will be the first cell to be iterated. Now, for this cell 7, find out what is the required or what is the demand and what is the availability. The demand here is 140 and the availability is 170. So we could easily satisfy the demand of this cell. So let me just mention 140 here. And make the demand to be 0. Since the availability is 170, I was completely successful in satisfying the need or the demand for this cell, that was 140. After satisfying a demand of 140 from 170, I am left out with 30 as the supply. Now your first iteration has been completed where you have already satisfied the demand for this particular column. Since the demand is turned out to be 0 and the demand has been completely satisfied for this whole column, let me try to strike this whole column out so that we could avoid the confusions in the later steps of the problem. Now after your first iteration for the whole given matrix, which was initially a 4 column and a 3 row matrix, now it has been turned out to be a matrix which has got 3 rows and 3 columns. Now to start off with this new whole matrix, find out the leastest value amongst the whole matrix. Find out the cell that has got the least value amongst all the cell values. Now, after striking out this whole column, I will not have to consider this for the second iteration. I'll only have to consider column number 1, 2 and column number 3 and row number 1, 2 and 3. Amongst this new row, the leastest value is 8. Now, 8 has been occurred twice. You can choose any of them arbitrarily. For instance, I'll be choosing this cell value. Here the demand is 120, but the supply here is 30. So I'll just satisfy whatever supply is there for this. And after satisfying a demand of 30 out of 120, I am left out with 90 as the demand and this whole supply will go out to be 0. Since the supply has been already turned out to be 0 for this whole row, I will have to strike out this whole row as well for avoiding all the other confusions for the next following iterations. So after 2 iterations, I have column number 3 and row number 3 striked out. Now at the end of the third iteration, at the end of the second iteration, I am left out with 3 columns and 2 rows. Amongst these, try to find out the cell which has got the least value. Now again, the least value will be 8. This column has got a demand of 90 and a supply of 130. Since the supply is greater, I would successfully be able to satisfy the demand of 90 and then turn this thing to be 0. Since the demand has been met, I will also have to strike out this column to avoid the confusions and the demand will be set to be 0 since it has been satisfied. After satisfying a demand of 90 or of 130, I am left out with 40 as the supply. Now after the third iteration, column number 3, column number 4 and row number 3 has been striked out. I am only left out with the 2 by 2 square matrix, that is 2 rows and 2 columns. Now for this new given matrix, find out the cell that has got the least value. Amongst all this, the least value is 10 and for 10 the supply is the demand is 90 and the supply is 40. So since supply is lesser, I will just try to satisfy whatever supply is there available and then try to strike this whole thing out. I'll just turn now the supply 0 since there was only 40 and the demand was 90. So I just satisfied the supply and I made the supply to be 0. Now after satisfying 40, the demand will be 50. Since this supply for the whole row has been turned out 0, let me try to strike this out to avoid the confusions. Now after the fourth iteration, I am only left out with 2 values in the cell, that is 2 cells, 2 columns and 1 row, and both the cells have got the same value. So arbitrarily I'll be choosing one of them. I will just choose this value first, where I will just choose this cell first, which has got a demand of 50 and a supply of 150. So since the supply is greater than demand, I would successfully be able to satisfy the demand of 50.
Since I'm satisfying the demand, I'll just try to mark the 50 here and I'll turn now the demand to be 0. And the supply, after supplying 50 items, I am left out with only 100 in the supply. Since the demand has been satisfied, this whole cell will also be, this whole column has also been striked out. Now I'm only left out with one and only one cell, which has got the demand also to be 100 and also the supply to be 100. So let me satisfy these. As we have already studied in the previous method, that at the end of the iteration, after applying any of the methods in the transportation problem, you'll be left out with only one cell where you have the demand which is completely equivalent to the availability, and this indicates that the given transportation problem is a balanced transportation problem and you have been applying the method appropriately. So now all the demands have been met and all the supplies has also been met completely. Now to end up the problem, find out the total transportation cost. Total transportation cost. You will just have to multiply these values and sum up with all the other allocated values in the values in the allocated cells. That for the first cell is 10 multiplied by 40. 10 multiplied by 40 plus second cell 11 multiplied by 50 plus third cell 11 multiplied by 100 plus the fourth cell 7 multiplied by 140 plus 8 multiplied by 30 plus 8 multiplied by 90. Now try to find out the sum for this. For the given transportation problem, the total sum is 3000.
Now we will apply Vogel's approximation method for the same problem. The same problem for which we applied northwest corner cell method and least cost cell method. Before I start solving the problem for Vogel's approximation method, let me tell you what are the different names given for the same problem. Second name for the same problem, Vogel's approximation method, is unit cost penalty method, or sometimes in short they may call it to be VAM, which is nothing but Vogel's approximation method. Okay. It's the same thing. In a similar way, first we have to find out if the given transportation problem is a balanced transportation problem or an unbalanced transportation problem. We are making use of the same steps where we will take the sum of all the availability, that is 130 plus 150 plus 170, which is 450. The sum of the availability 130 plus 150 plus 170 is 450. For our convenience, I'll just write it so that I just don't want you people to get confused about the values. Now, take a sum of the required, that is nothing but the demand, 90 plus 100 plus 140 plus 120. This will also give me a sum of 450. Now, with this, I conclude that the given problem is a balanced transportation problem. Now, to apply Vogel's approximation method. To apply Vogel's approximation method, first I'll have to find out the row difference and the column difference. For each iteration, I will have to check for row difference and column difference. Now, for the first row, find out the least value in the first row. The first least value in the first row is 8. And the second least value in the first row is 10. So what is the difference now? 10 minus 8. The difference should give me 2. Similarly, proceed with the second row. The first least column is 9. First least value is 9. Second least value is 10. So 10 minus 9. The difference will give me 1. And then come back to the third row. First least value is 7. Second least value is 8. The difference will be 1. Now follow the similar steps for the column, since we also have to go for column differences. Now the least value in column number 1 is 10 and the second least value is 11. So the difference will be 1. And in the second column the least value is 9, second least value is 11. So the difference will be 2. In the third column the least value is 7 and the second least value is 9, where the difference is 2. And in the third column, now we came across a scenario where there are only 3 cells in a column and 2 cells have got same values which are supposed to be the least value amongst the other values in the column. So now the least value here is 88 in this fourth column. Similarly, I have one more 8 present. So what I will do, I will just try to find out the difference between these two least values. No problem, it will just be 0. Now go for the iteration. Now amongst these column difference and row difference, identify the largest value. Which is the largest value? 2 is the largest value. Which one will you choose? There are 3 2's present. Even in row difference I have 1 2 and in column difference I have 2 values of 2. So what I'll do, I'll choose any one arbitrarily. For instance, I will just choose this 2. This 2 is a difference of values in the row 1. So you will have to consider row 1 now. Now amongst the row 1, identify the cell with the least value. 8 is the cell with the least value. So now this is the first cell that I'll be encountering. What is the demand for 8? 120. And what is the supply? 130. What happened? I will just write the least value, that is nothing but 120, indicating that the demand has been met, and after supplying 120 demand, I am left out with 10 more units in availability. And then now you're done with the first iteration. Go for the second iteration. Even in the second iteration, you will have to find out for the row differences and column difference. Now, since before I go for the second iteration, since this demand has already been met, I will just cancel out all this values in this column. Now, since the demand has already been met, even if I choose either of these in the further iterations, I will not be able to identify the demand since it is 0. So I will just strike this whole column out. Now this is the new matrix that I find after the first iteration with 3 rows and 3 columns. Now to start with the second iteration, consider this new matrix and find out the row difference and column difference for this new matrix. What is the row difference here? The first least value here is 10 and the second least value is 12. So what is the difference? It is 2. And then come back to the second row. The first least value is 9 and the second least value is 11. The difference is 2. And amongst the third row, first least value is 7 and the second least value is 9. So again the difference will turn out to be 2. Come back to the column number 1. Column number 1, since there are no changes, the value remains the same. Again, the least value is 10 and the second least value is 11. So the difference will be 1. In column number 2, the least value is 9, second least value is 11. The difference remains to be 2. In column number 3, the least value is 7 and the second least value is 2. I will just mark a hyphen mark for the column number 4 since it has been striked out. Right? So now we are done with the second iteration's differences. Amongst these, find out the largest one. The largest is 2. Now since 2 is present more number of times, in row differences I have 3 occurrences of 2 and in column differences I have 2 occurrences of 2. So what I will do, I will choose any one of them arbitrarily. I will just go on choosing first from row. So I will just consider this 2. This 2 is the sum of row 1. Amongst this new matrix, find out the least value in the first row. What is the least value in the first row? 10. And what is the demand here? Demand here is 90 and the supply here is 10. So what I'll do, I'll satisfy the demand by 10 and I'll have 80 carrying forward. And this demand will turn out to be 0. Okay. Now we are also done up with the second iteration where we are striking out the first row. Why? Because this availability for the row 1 is completely nil. So I will not be able to allow any of the other columns to choose the row values. So to avoid confusions, we will just try to strike it out. Now after your second iteration, your column number 4 and row number 1 has been striked out. I now have a new matrix with 3 columns and 2 rows. For this new matrix, find out the row difference and column difference. Now what is the row difference here in the second row, or for the new matrix this will be your first row. Again, the least value is 9, second least value is 11. So what is the difference? Difference will be 2. I will just mark a hyphen since I have striked out row number 1. Similarly, for column number 2 in the new matrix, least value is 7, second least value is 9. So the difference remains out to be 2. Once again here, column number 1, now I have only 2 values in column number 1. So what is the difference between these two? 12 minus 11, sorry, 20 minus 11 will give me 9. And 11 minus 9 will give me 2. And 9 minus 7 will give me 2. And this column has been striked out, so I will just mark a hyphen mark. Now, amongst this new iterations, column difference and row difference, identify the largest value. 9 is the largest value here. So, encounter this. And 9 is a difference from column number 1. So, amongst this column number 1, identify the least value. Least value is 11. What is the demand here? 80. And what is the supply available for row 2? 150. What I will do? I will meet the demand successfully. And the demand will be closing out. Since the demand has been met, this whole column will be striked out. And after subtracting 80 out of 150, I am left out with 70. Okay, and this is the new matrix I come up with. After completing 3 iterations, I come up with a new matrix where there are 2 columns and 2 rows. And after completing 3 iterations, column number 1, column number 4 and row number 1 has been striked out. So for this new matrix, identify the row difference and the column difference. Column difference. So this column has been striked out, so I'll just mark a hyphen mark. And I'm only left with 2 values. So 11 minus 9 will give me 2. 9 minus 7 will give me a value 2, and then 11 minus 9 will give me a value 2. Okay, row number 1 also I'll just mark a hyphen. 7 minus 9 or 9 minus 7 will give me 2. Again here the differences remain 2 or constant. Amongst column difference also I have 2 occurrences of 2, and among row difference also I have 2 occurrences of 2. So now I will randomly choose any of these values. I will just choose this 2. Now this 2 is a difference of from the new matrix, it's a difference between first row. Amongst this first row, identify the least value. What is the least value? 9 is the least value. And what is the demand here? 140. What is the supply here? 70. So I will just satisfy the demand by 70. And still 70 is being carried forward. And this whole availability will turn out to be 0. So what I'll do, I'll strike out this whole row. Right? Now go for the last iteration. Now, now after your 4 iterations, column number 1, column number 4, row number 1 and row number 2 have been striked out. We are only left out with 2 cells which make up 1 row and 2 column. So now amongst this new matrix, identify which is the identify the differences. You can still identify the difference since it forms to be a row. 9 minus 7, the difference will be 2. And I'll just mark a hyphen for all the other 2 rows which has been striked out. And this column is also striked out, so I'll just mark a hyphen. And column number 2, the value is 9. Column number 3, value is 7. And column number 3 has been striked out from your last iteration. So I'll just mark an hyphen mark. Now, amongst these 3 values, identify the largest value. Largest value here is 9. And 9 is the value that we find in column number 2. Since there are no other values to identify the least value, I will just have to consider 9. And for 9, the demand is 100 and the supply is 170. So what I will do, I'll just satisfy the demand of 100. And the demand will turn out to be 0. Since the demand has been met, this whole column will also be striked out. And now this is the last step where I am only left out with 1 cell, that is 7, where the demand is also 70, and after satisfying this I will be left out with 70. Where the demand is also 70 and the supply is also 70. So now this indicates that the given problem is a balanced transportation problem and you have been appropriately applying Vogel's approximation method to find out the right answer. So now we are left out with all the we have met all the demands and supply successfully, and we have also made allocations for the
values in the matrix. Now to find out the total transportation cost. You have to multiply these values with each other and sum up with the other products from the other cells. That is 10 multiplied by 10 plus 11 multiplied by 80 plus 9 multiplied by 100 plus 9 multiplied by 70 plus 7 multiplied by 70 plus 8 multiplied by 120. That's all. So how many allocations you have made? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now find out the total for this. The total is 3960. This is the way now how we apply Vogel's approximation method for a given transportation problem. Thank you.